All right. Hello, everybody. Welcome to Premiere 2022. We are all so excited to have you here today. Today, we have a great session talking about physics with one of our great professors in that department. I do want to point out at the bottom of your screen, there is a Q&A section. You're more than welcome to submit any questions you have down there. But without further ado, I'm going to pass it off to Dr. Russell.
All right. Well, thank you very much. And thank you for everybody being, well, wherever you are, but being able to join us today. I am Dr. Russell, and I'll be talking a little bit about the department. And I wanted to introduce to you Weston Hall, who will be handling the chat and answering questions through there. So if you'd say hello, Weston. And
Hi, everyone. I'm Weston. I'm an undergraduate here at Baylor, and I will be answering some of your questions.
Okay. All right. Well, thank you, Weston. And I'll go ahead and get started, try to share my screen and do the PowerPoint. So let's see how we do here. All right. Is this, hang on a second. Well, is my screen sharing right now? Because it seems to be not allowing it to. Here we go. All right, can you still hear me?
Yes, we can.
Okay, can you see the screen now? Because I can't see I don't see the chat as I'm doing this.
We don't see the screen. Do you want me to try and share it on my end?
Yeah, let me look one more time here and see if it will do it. I think it will now. How about now?
Yeah, we can see it.
All right, great. Sorry for the technical glitches. Well, welcome again. I'm going to be talking about the physics department and a few of the things and just about physics in general and what the opportunities physics provides for you and some of the benefits from coming to Baylor and our physics department. We do have advantages of being a major American university and with a Christian basis and a strong academic programs. And you might have heard today that we've just achieved R1 status. So that's just a wonderful recognition of the level of research that we strive for here at Baylor and in the physics department. And also, it just opens up opportunities that we may not have had before. So we're very excited about that. And the department is around 15 faculty. So we're a small and a close-knit group, and we have a lot of opportunity for interaction between the faculty and the students, both undergraduates and graduates. And we do have a variety of research opportunities here. We have 6 research labs and 5 different theoretical groups going on in the department. So we'll talk a little bit about them. And you can see that we have picnics and have a good time together, and as well as doing the research. All right, one of the things that our undergraduates has is a physics society, and the society is one of the ways students get together. I think Weston might agree that the camaraderie that comes from being a group in a physics class can be also a good interaction as well. Struggling through the challenges of the courses is very rewarding. But we have things other than that. We have intramurals and luncheon luncheon for graduating seniors, which is also an opportunity. The physics club has an honor society, Sigma Pi Sigma, and that's an opportunity for induction into that as well. There's community outreach. We've had different activities, but one that's fairly regular is that we form groups that work with Habitat for Humanity on working on houses in the city. And then just some of the more getting together things, physics game nights. Students design a t-shirt and have a t-shirt sale during the year. And then a regular Friday Donuts is part of the department. So a few things about our majors. We have a variety of options for our majors, both BA and BS degrees. We have in astronomy and astrophysics, specifically in physics, we have different concentrations. We have the straight physics degree, but we also have bachelor's of science with concentrations in different areas. Computational physics, pre-health, which would be an option that some people going into medical school would consider. That's one there. And a newly formed one that's a BS in physics with an education concentration. If you're interested in pursuing teaching, but you want a full physics training as part of that, then that's an option that's available. And beyond the bachelor's level, we have the master's and PhD programs as well. Why major in physics? This is a graph that shows the 2018. This is kind of the latest data that they have presented so far, where starting salaries are in different fields, particularly business and scientific fields, and physics fares fairly well. And the range here is, like it says at the bottom, 48,000 to 68,000 is a typical range for starting salaries with a physics degree. A distribution of where students go. Oh, hang on. With it. And also, if you're looking at the bottom here is the website you can go to look up this information for yourself. And so you have that opportunity as well. But a little over half go on to graduate study. So they want to either obtain a master's or a PhD in the field. And of the others, you can see kind of the breakdown here. With 34% fully employed, and we'll show a little bit about the different areas that physicists go into. Not here. All right. And starting salaries in the private sector as a breakdown of your degree with PhD in physics. There's a wide variety because physicists tend to do a lot of different things depending on their interests. But this gives you an idea of the different ranges with the different degrees. And who hires physics majors? And this is specifically for a bachelor's degree they're looking at here. And in the private, of the ones not going into graduate school, fully 66% go into the private sector. And here is a list of sampling of companies that physicists will go into. And we've certainly had our students go in, work for some of these companies and also move on well into the private sector if that's their choice. Let's go ahead. If you're interested in pre-med, this isn't a traditional path for going into pre-med. Biological majors are clearly, you can see here are the numbers of students doing the different paths. But of the ones who do physics, they do very well. They actually have the highest averages on the MCAT and LSAT, the for going to law school as well. And we've actually had students that have finished degree, gone on and gotten a PhD in physics, and then went to law school after that. So, because certainly there are a lot of technical issues in legal fields as well. All right, so I do want to get on and talk a little bit more about the department. And even though we're a small department, in some ways, we're quite active. And I will encourage you to do a couple of things. One, go to the Baylor website, the cover page, and scroll down to the different stories that are presented. Two of the stories are from research going on in our department right now. So that's pretty exciting and shows how active we are as a department. Also, another thing that's pretty exciting about Baylor at this time in physics is if you do come, then in 2 years from yesterday, there's going to be a total solar eclipse that is going through Waco, and the physics department is actively organizing both viewing of that, outreach, and a conference, professional conference that will be organized around that event. And so you'll definitely be able to be part of that. And if you saw the last eclipse, it lasted about, I believe, 1.5 minutes. This one's going to last almost 4 minutes, so it's going to be even more dramatic. In the research, we have quite a variety. Much of it is in the area of material science. We have a quite active experimental work in there. This is basically material science. We're doing electronic materials, trying to create new materials, and then do characterization of materials at the atomic scale. And Dr. Zenron Zhang's research on that's represented in one of those articles is kind of cutting edge in that field. So that's a very interesting one. We also have high energy experimental with a permanent setup with the Light Hadron Collider at CERN in Switzerland, where they're active year round in that. We have space science that works on plasmas that can represent space environment effects. We have nonlinear dynamics. This is chaotic behavior in systems. And we also have active research and theory, particle physics, 2 types. We have QCD loop calculations, and we also have lattice gauge theory used to study quantum chromodynamics. And then we have string theory, quantum gravity, and cosmology is another active field there. All right, that's a lot of material very fast, but I think we managed to cover things in the time allowed. And here's some contact people. And again, my name is Dwight Russell, and you're welcome to contact me at any time as well if you have additional questions. So, all right, do we have questions at the moment? And Kelsey, do you want to help us handle that?
Doesn't look like we have any questions yet. If any of you have questions, feel free to submit those in the Q&A portion down below. Until that point, Weston, do you want to give us a little bit of information about why you chose physics?
Sure. So if you remember at the slide with the different tracks, I'm actually an astrophysics major. So I take almost all the same classes as the physics majors, just with some extra astronomy labs on the side. And it's something I've always been interested in. The faculty's been really great. I've gotten involved in research a whole lot. And I've been working with Dr. Endel on planning the eclipse stuff for 2 years, as Dr. Russell mentioned. Yeah, I just loved it here, and I've been here for 4 years now. So that's why I chose it.
Looks like we have a couple of questions now. First one being, does physics play a huge role in electrical engineering?
Um, yes, yeah, there are different answers to that question. In terms of the field of electrical engineering, the way it's done now, it basically is a outgrowth of physics that was done 50, 60 years ago, and the solids, all the things that in terms of transistors and integrated circuits began with the basic physics process. So there's a lot of overlap in the material science we do and types of work that's done in electrical engineering. And this is something that we actually encourage, to this collaboration between the two, because they're able to benefit from each other, both in resources and just ideas that come about. So in that sense, yes, there's a big connection. In terms of if you're majoring in electrical engineering, there's a requirement that you take a year of physics. There would be the 1420, 1430 courses that are offered in our department. And so we definitely get an interaction that way. And but we will encourage you to think about physics if you show an interest, even if you start out as an electrical engineering major. So we do get a chance to interact with you all in those classes. I hope that was answering your questions, but I'm happy to do more if you have questions along there.
Looks like we have a couple more kind of off of that answer. Can you double major in physics and engineering?
Yes, you can. What you would need to look at is meeting the degree requirements of both and what that's going to take to do. And so, but certainly it's something that you can consider. Yeah.
And one more on that topic, how would you say a physics major and engineering in general, that major compare?
Well, okay, this is definitely from a physicist's point of view. So, but there's a saying that goes on: if you're an employer and you're looking for someone and you know exactly the kind of person you need, you hire an engineer. But if you're not sure what kind of person you need and you need someone to just look at the problems and in a general way and figure out what to do, then you hire a physicist. So that's kind of the difference that is classically talked about there. So yeah, we think there's a bit of a different way of thinking, but from a physicist's point of view, we try to be a little more open to a variety of approaches. I think that's, again, our bias. And so that's the answer to that. If you have a specific area that you want to work in, a specific field, that maybe engineering is the best, but if you're more interested in problem solving in a variety of different ways and having that kind of flexibility, we think physics is the way to go.
I was just going to add that I have a good friend who's a physics and engineering double major. So it does exist, but he says that it is definitely more rigorous than just doing a single major, but there is a little bit of some interplay because physics requires some STEM elective classes that engineering can substitute in for, but you just have to look at the requirements for that. And then I also have a couple friends who are just physics majors that are actually looking to attend engineering graduate school later on. So it's not unheard of to switch back and forth in between the two after graduation.
Another question, what kinds of scholarships exist for physics students?
I don't know that I have a complete answer for that one, but there are departmental scholarships that are available. They're usually not awarded until after the freshman year. But if you get in contact with me, I will, Dr. Jay Dittman, I believe right now, is running the scholarship committee, and he'll have the latest information and we can get that to you.
I was actually the recipient of a physics department scholarship 2 years ago. So the application process is pretty simple. I'm pretty sure on the Baylor Student Financial Services website, there's a departmental scholarship area. If you just search for physics, it'll show you the ones that are usually there.
I'm hopeful that there may be some new ones coming up too, because we've had some generous donations lately that hopefully will increase our scholarships. So stay tuned.
Another question, what do you recommend I study or practice before my freshman year begins? I'm going into astronomy and want to be well prepared for my first year.
Well, Weston might have a good answer. Well, I'll let Weston answer first since he's experienced the major.
Sure.
And I'll join in if you need something else.
Yeah, the coursework really starts you from the ground up. You actually don't take your first astronomy class until sophomore year. So just going through the basic physics 1 and 2, 1420, 1430, like we talked about, should prepare you as much as possible. I didn't take any astronomy classes in high school. So the sophomore year was the first time I took one, and it turns out pretty well. So yeah, I think as long as you get through the firit should be fine. They will prepare you ahead of time.
Yeah, so I'll just add to that. Yeah, if in high school before you come to Baylor, since physics is the first thing you encounter, then preparing the math skills and the physics skills, anything you do for that is the best, because you'll start with calculus and the introductory physics. Also, if you get a chance to just have a telescope and in your free time practice learning how to see the sky, then that never hurts either.
On a similar note, what kind of equipment is provided?
For with any particular area or just general?
It looks like for astronomy.
For astronomy, we have on campus a variety of telescopes that are kind of the small portable ones, the 6-inch to I believe the largest that we regularly use is an 11-inch. And we also have CCD cameras that can go with this. The next level up is we have a connection with the Paul and Jane Mayer Observatory that's about 40 miles from here, that has a 24-inch mirror telescope and totally computer controlled, and is good for training and doing, but you can do exoplanet transits and things like that on that. But ultimately, Dr. Endel has a connection with McDonald Observatory and has an active research grant there that she's happy to have undergraduates involved with. And astronomy's changed. It's not just observing anymore. They have huge databases of information. So it is part of data science and data mining, because they right now have so much information online that you have to learn skills to analyze it and learn what you're looking for. So that's a whole new area of astronomy and many other fields that wasn't there 30 years ago.
Yeah, I can add that all the research I've done in astronomy in the last 4 years, besides I was a bit more on the theoretical side, but all the work I did was with data from space telescopes, K2 and Gaia and other surveys like that. So there's just a lot of information out there without needing to actually go to a ground-based observatory.
Okay, well, unfortunately, we are out of time. So thank you for attending. And thank you, Dr. Russell and Weston, for your information. If you guys have any other questions, feel free to reach out to the contacts on the screen. Have a great rest of your day.